Okay, so we're going to talk about parabolas that have some number that is multiplied by the square term. So remember, a parabola is y equals something times x minus h, quantity squared, plus k, where hk is the vertex. So the red parabola right here is the parabola that it opens downward, and it has been moved one space to the right of where it would normally have its vertex on the y-axis when we just have something like y equals x squared. And then also we've added 2 to the function and scooted it up 2 spaces. So that would be the basic y equals x squared parabola moved 1 to the right and 2 up. Now, the blue parabola looks just like it, except now we're multiplying the square term by -3. So now instead of looking just like the regular y equals x squared parabola, it is skinnier. So when you have a coefficient on the square term that is greater than 1, absolute value is greater than 1, then you're going to have a skinnier parabola. When you have a number multiplied by a square term like this, where it is between 0 and 1 in absolute value, that's going to give you a fatter parabola, wider parabola. So we're just going to look at a couple of examples so we can see how we would deal with that in an equation. So we have an equation here of a parabola, and first of all, we would want to get it into the form where we would have y on one side and all the other terms on the other side. So we would have 3y equals x squared minus 2x minus 5. All right, normally we would want to write the function just y equals something, but since we have to complete the square on the right side anyway, we'll just leave that 3 where it is for the moment so that we don't have it in the way. So to complete the square, to get this in the right form, we are going to put a blank here and another blank here. We will add half of 2 squared. So half of 2 is 1. Square it, you get 1. And we'll also subtract 1. So now we can rewrite this as x minus 1 quantity squared minus 6. So that is 3y. We don't want 3y, we want y when we're talking about a function. So we're going to divide both sides by 3. And to do that, we're going to put 1/3 right here in front of this term. So we've divided that term by 3, and then we're going to divide the 6 by 3 to get 2. So this is the equation of the parabola, and this is the parabola where it has been moved 1 to the left, and it's moved down 2. So the vertex is going to be 1, -2, so here. So first of all, we know that the axis of symmetry is the vertical line that goes through the vertex. So it's going to be that line right there, the line x equals 1. And then we can pick some other points. If I put 4 into this equation, if I put 4 in, I'll have 1/3 times 4 minus 1, 1/3 times 3 squared. So that's 3 minus 2 is 1. And so since this is symmetric about that blue line, we're going to have another point just like it, 3 away from the vertical line. And so we can kind of get an idea. We can pick a couple of other points that are easy to pick. So then we can draw that parabola and we see what it looks like. And it's a little bit wider than what our y equals x squared parabola would be. So whenever you have a number multiplied by the square term, and that number is between 0 and 1 in absolute value, you're going to get a wider parabola. Okay, so let's look at the next one. Here, we want to complete the square to graph this parabola. And so to do that, we're going to have to divide both sides by 2 because we can't complete the square if we have this 2 sitting in front of the x squared term. So we'll divide both sides by 2 temporarily so that we can do the completing the square. So we'll have y over 2, and then we'll have x squared plus 6x plus 17 halves. So if we're going to complete the square, again, we'll put a blank after the x term, plus blank, and minus blank. We're going to take half of 6, which is 3, square it, and that's 9. So now we can write this as x plus 3 quantity squared, and then you got 17 halves minus 18 halves is negative 1/2. And since that is y over 2, we need to go ahead and multiply both sides by 2 again to get that y by itself. So we'll have y equals 2 times x plus 3 quantity squared minus 1. So now we have the parabola where the vertex is going to be -3, -1. So if we put that vertex there, -3, -1, and then we can pick a few more points and just try them out, like put in -2 for x, and you will get 2 times 1 squared, which is 2, minus 1 is 1. So you can just plug in a few more points to get a better idea of what this is going to look like. And you've got your axis of symmetry right there through the vertex. And so it's going to look the same on both sides of that. And you can see that it is more narrow than our normal parabola, than the basic parabola. Okay, so I wanted to real quick go back over the period change again, just to make sure it made sense. So in general, when you have a different period besides 360 or 2 pi for your sinusoid, you are going to be able to find the coefficient on theta in your equation by dividing 360 by the period if it's in degrees, and 2 pi by the period in radians, and that's going to be the coefficient on theta. So let's just look at how we would do this. So on the one on the left, first of all, you can see what the period is going to be, because this is what the function does. It does that same thing over and over again. And so it does it one time and again and again and again. That's just all this function does. It does it in 90 degrees. It completes that cycle. So the period of this sine curve is 90 degrees. And then we can look quickly and see the horizontal axis is 10, the amplitude is 2, and there is no phase angle. It hasn't been scooted over at all. So when we want to write the equation, we can think about what information we need to put in there. The coefficient on sine is going to be 2. That's the amplitude. The number we're adding to the function is 10. And then what is the coefficient on theta? Well, we know the period, so we're going to put 360 over 90. The period's 90 in this case, and that's 4. So that is the coefficient on theta for that function, for that equation. Then for this cosine function on the right, you can see that what it does is it starts at the top, goes all the way down, and then back up again. And that's what it does over and over again. On the x-axis, it did one full cycle by the time we get to pi. So that is the period. The period of this cosine function is pi. And so our amplitude, our horizontal axis is -10, and our amplitude is 3, and there is no phase angle again. So if we had this equation, we're writing it as a cosine now. First of all, we can put in the horizontal axis as -10, and then we will put 3, the amplitude, as the coefficient on cosine. And then to figure out the coefficient on theta, we're going to say 2 pi over the period. So 2 pi over pi in this case, and that is 2, and so that will be the coefficient on theta.